All right, today we're going to talk about are rational exponents. So we've dealt with exponents and square roots before, but now we're going to talk about something, the specific parts of them. So in this case, when you have an exponent that's a fraction, the denominator is called the index, and you can actually rewrite that with a radical. So whatever your denominator is for your fraction exponent, your rational exponent, that's going to be the index of your radical. And then whatever is the numerator of your fraction is going to go inside. So this is the radical, and then that inside part is called the radicand. And then as we said here, your exponents go right there. All right, so just a reminder, if no index, so remember this is the index, if no index is written, then the index is assumed to be 2. That's your square root. That's what we're used to dealing with. So it would be a square root. And if no exponent is written, then the exponent is 1. So make sure you get that written down, or just as a little reminder for you. And then we'll talk about this in a second. But I want to go here first. So what we can do is we can take our rational exponent and rewrite it with a radical. And as I said, this top number is going to go inside with the radicand, and your denominator is going to be the index. So what this really means is you need 3 groups. So this 64 is the same as saying, 4 times 4 times 4. And every time you've got 3 groups of 4, you kick it outside. So if you notice, since my index is 3, every time I have a group of 3, you're going to take your radicand outside, which would be 4. Or if you think about it, your cube and your cube root cancel each other out, so you're just left with 4. All right, so let's look here. If we were to look here, I've got a group of 3 x's, and then it's all over 5. So we can rewrite it as x 3 to the power. So that's all this means. Now, if I would have had here, and our index is 3, every time we have a group of 3, it kicks outside the radical, which is 4. All right, so now this one is where it starts to get a little tricky because our index is 4. So now we're going to look for every time we have 4 of something, it gets kicked outside the radical. So 16, we can rewrite. I'm going to erase this real quick. I'm going to do the long way for you. I'm going to go 2 times 2 times 2 times 2, and then we have 8 m's. Holy guacamole, that's a lot. So every time you have a group of 4, you're going to kick it out. So I've got 1, 2, 3, 4. This is going to go outside the radical. And then I've got another 1, 2, 3, 4. This is going to kick outside. So it's another group of 4, so that's where we get our m. And then if you look here, I've got yet another group of 4, which is going to kick here. So this is actually, that's why we have 2 groups of 4. So we've got our 4 groups of 2, which is this one. And then our m is really your 2 m's from here. So every time you have a group of however many the index is, you kick it outside the radical. All right, so now let's talk about rewriting. So we're just going to take our radicand, and that's now your base. Your exponent is the numerator, your index is the denominator, and this is as simplified as you can get. So I want you to try this one, and then like I said, use your examples up here to help you. Oops. And then now, let's go ahead, let's try this one. It gets a little tricky. So first off, on yours, you did not have a 1 written there. So what I usually do is I'll go through And remember we said that if no exponent is written, then the exponent is 1. Oh, sorry, my iPad's going crazy there. So what I usually do, just so I don't make a silly mistake, is I write in an exponent of 1. So that will help remind me that it's there, because usually kids will forget about it. So I've got my base of 3. I've got the exponent of 1 and your index of 2. Now again, this 2 was not written there, but if what I said here is if no index is written, then your index is 2. So let's go back here. So I'm going to write in a 2, just as a reminder. All right, so now I've got my index of 2. So now I'm going to go to the radicand, which is your base. The exponent becomes a numerator. The index becomes a denominator. Now here, we've got under the radicand, we've got y, which is your base. We've got your exponent as a numerator, your index as the denominator. Now, these are okay. You can't simplify them anymore because you don't want to write a decimal. So these fractions are as simplified as you can get. But I want you to look at this one. 8 over 2 equals 4. So since we can simplify that, we're going to rewrite everything and make 4, because this does simplify to a whole number. So that's your answer for there. All right, so now let's look here. Now in this case, your index is 3. So every time you have a group of 3, it's going to kick outside the radical. Or, here's another way you can do it. So I'm going to take this 8 and I'm going to rewrite it as 2 to the 3rd power. So remember, your exponent is going to be the numerator, the index is going to be the denominator, and we're going to do the same thing here. 9 over 3, and then 5 over 3 with the correct base. Now you can simplify this, so you're going to get 2 to the 1st power. This you can simplify to make 3, and you cannot simplify 5/3 anymore, so this is your final answer. All right, so now we're going to rewrite each expression in radical form. So our final answer needs to have the radical with the index here. So we're just going to work backwards. So again, you write your base as the radicand, your exponent or your numerator is the exponent, your denominator is the index. Now on this one, all of the fractions have the same denominator, so your index is going to be 3. So this is all to the 3rd root. And we only have 1, 3, but we have m to the 2nd power, and we have n to the 7th power. Now we can, since this one is actually greater than 3, if you were to have 7 n's, you can put them into 2 groups of 3 with 1 guy left over. So our 2 groups of 3 is right here. So those got kicked outside the radical. And then we had, oops, did I count that right? I think this one should just be in. There you go. All right, so, and then you can think of that because you've got 6 n's and you have 1 n left over. All right, and then that is your final answer right here. All right, let's go ahead. Now this one's a little different because here you do not have the same denominator, so you don't have the same index. So you need to get a common index first. So basically you're going to do equivalent fractions or common denominators. So what I did was I took 1/3 and I made it to 4/12. 1/4 is 3/12, and 3/2 is 18/12. So now that I've got this, I'm just going to rewrite it. Since we have the same denominator, our index is going to be 12, and then 3 is going to be your exponent, and 18 is going to be your exponent. Now, this would be okay. However, if you look at this one, we can make a group of 12 out of that. So we can take 12 from here and we're still left with 6 over 12, which is where we get the 6. So we kicked out a group of 12 and we have 6 left over. All right, now on this one, originally, there's a couple different ways to think of this one. I'm just going to kind of show you a very basic way. So the 4 and the x both have an exponent of 1. So we can actually distribute this 1/2 to each one. And then that's where I got those two exponents. And then here goes that. So now if you notice, they all have the same index. So we're going to rewrite it all under a radical with an index of 2. And truthfully, you don't have to write the 2. But here's one little trick. If you notice here, we have 4 to the first power, but 4 to the first power is the same as 2 squared. So we're going to start rewriting this. Since I have a group of 2, I can kick this outside the radical. And then here, I've got x to the first, and then I've got 7 over 2. So again, we can do 3 groups of 2 with 1 left over. So it's just a different way, and worse comes to worse, if you need to factor it all out and circle how many groups you can do that too. But that's how you would simplify it. All right, so now we're going to go simplest radical form with constants only. So basically what you're doing is you're breaking the fraction exponent apart and then you're simplifying. So, 36, you can write this a couple different ways. I could do, in this case, 6 squared is the same as 36, and then do 2 6 over there. So you want to make sure when you're doing this that you have 2 6, or if you know right away, hey, here's what I'm going to get is 1/3, and then you go ahead and write 3 over there. You could factor it all out, but you'll see it all end up being groups of 2 and groups of 3. So it'll end up being the same thing underneath. So anyways, we're just basically breaking this down and then writing your fraction from there. All right, I want you to try this one, so I'll give you a hint. 25 is 5 squared. And then go from there. All right, now this one, 125, is the same as 5 to the third power. Now, I usually try to get it in terms that you can simplify here. Well, in this case, it just happened to work. So I've got my base of 5, and then I have 3/9 as your exponent. This can be simplified to 1/3. So now once we're here, now we can rewrite it with the radical. So it's a cube root of 5. All right, I want you to try this one. So again, I would break this down into 2 to the third power, and that will help you. All right, so now let's just simplify using exponent properties. So this is a review, but whenever you are multiplying the same base, you're going to do the product rule, which means you add the exponents. So I'm just taking these two and I'm adding them together. And you're going to get 3 over 3, which equals anything to the a to the first. Oops, I forgot to write a. I was like, that doesn't look right. Ooh, you guys get pretty colors. All right, let's try it again. All right, so that is the product rule. All right, so now let's look at the quotient rule. So the quotient rule says when you're dividing the same base, you subtract the exponents. So we're taking 2/5. So since we have the same base of m, you're taking the numerator minus the denominator. And then 2/5 minus 1/5 is 1/5. So you could either write it as your rational exponent, or you can do the 5th root of m. All right, now this one has 2 rules that you need to remember. First is the power rule. We actually already did the power rule before, where you distribute, and remember I said I usually write in an exponent. So I remember, but you're going to take, if you're multiplying, if you're taking a power and another power's outside, you multiply. So I like to think that I'm distributing the exponent to all the other exponents inside. So I'm going to get x to the negative 1/3 and y to the negative 2/3, because 2 times negative 1/3. Now, here's where we're going to get into our negative exponents. When you have negative exponents, now I wrote in here flip, but really what you're going to do is you're taking whatever has the negative exponent, the base that has a negative exponent, and if it's in the numerator, you're going to move it to the denominator. And when you move it to the denominator, because this is all technically over 1, when you move this to the denominator, you're going to change the sign of the exponent only. So if you notice, it was minus there, but in the denominator is actually plus. And there is a pattern where you keep subtracting exponents and then it flips to get to a fraction. And then you're going to go ahead, and since this is negative, you're going to flip it or move it to the denominator. And once you move it to the denominator, you're going to change the sign of the exponent only. So, and it could work vice versa. If you have a negative exponent, you could also move it up if it's like negative 1/2. So just as an example, if I were to have 1 over x to the negative 2/3, I could take this and move it up to the numerator and be x to the positive 2/3. So just be careful when you're doing that, because negative exponents trip people up all the time. So remember, since this was technically a fraction over 1, we still need a placeholder for the numerator, and your denominator is now going to have your positive exponents, and you can write it like this, or you can rewrite it with your radical. And then remember, since these both have 3 as a denominator, that's going to be your index. And then your numerator is 1, numerator is 2. And so either would be correct for that. So that's a lot of rules for rational exponents. Just remember the parts of it and how to write it as a fraction. And then last but not least, this is what I was talking about before. If you were to have 10 over 2, that equals 5. If you were to have 11 over 2, you have 5. Oops, I wrote this here. I'm catching all my mistakes as I'm going over it. So you were to have, and I think I did the same thing down here too. Wow, I'm tired. There you go. So every time you get a group, if we have 11 over 5, you've got 5 groups, which would make 10 with 1 left over. Here, since your index is 3, you've got 10 over 3, so you have 3 groups with 1 left over. All right, and that is your rational exponents.